Hi everybody, welcome to today's Saturday session with ExamRevision. So this video is for Leaving Cert higher level maths students. We're going to take a look at algebra, and in particular we're going to focus on how the factor theorem and discriminants have come up in exam questions over the past couple of years. Okay, what we'll notice is they're very regular exam questions, and the questions on each of those subtopics tend to be quite similar. Okay, so we can prepare quite well for them. So we're going to divide this session up into two. So we're going to look at the factor theorem, we're going to look at roots and factors, do a bit of revision of your long division from junior cert as well at the start. And we're going to then work on to discriminants to determine the nature of the roots of a quadratic. Okay, we're going to focus a lot on exam questions. We are going to go through the kind of basics of it before we dive into the exam questions. But the main focus of this video will be how it has come up in past questions. So we're going to start with revision of long division in algebra that you would have seen at junior cert. I know some people might do this with the box method. For any of these factor theorem questions, I'm going to do it using this layout. So long division with algebra. This does take a little bit of practice, but once you kind of get it, you get into the flow of it, and then it's all repetition from there. So we want to divide x plus 3 into 2x cubed minus 3x squared minus 17x plus 30. Okay, so my first step, I'm going to take this x, and in my head I ask, what will I multiply x by to get 2x cubed? So to go from x to 2x cubed, we have to multiply it by 2x squared, and we write that up on top. That's step one. Step two then, we're going to multiply 2x squared by x, and then by 3. Okay, we multiply those separately. So first we're going to multiply 2x squared by x to give me 2x cubed. And then we'll multiply 2x squared by 3 to give me plus 6x squared. Once I have two numbers written, I draw my line underneath. And in a different colour, I'm just going to mark it so I change the sign of both parts. So it was a positive 2x cubed, I'm going to change it to a negative. This is a positive 6x squared, so I'm also going to change it to a minus. Okay, now I'll fill in this next line. So we've got 2x cubed minus 2x cubed, they'll cancel out. Then we've minus 3x squared minus 6x squared, which is going to give me minus 9x squared. Okay, that minus 9x squared is on its own, so we're going to bring down the next term, which is minus 17x. And once you get that far then, we're actually just starting again and repeating the full process, but we start with this number. So we have x, and my question in my head is, what will I multiply x by to get minus 9x squared? So to go from x to minus 9x squared, you have to multiply by negative 9x. Okay, and then we need two numbers to go underneath here. So we're going to multiply minus 9x by x. So minus 9x multiplied by x will give me minus 9x squared. And minus 9x by 3 will give me minus 27x. I have two new numbers there. When I have two new numbers, I draw a line underneath and I'm going to change the sign. This will become a positive 9x squared. And this will become a positive minus 20, or a positive 27x. So minus 9x squared plus 9x squared cancel out, 0. And then we've got minus 17x plus 27x. That's going to give me 10x. And bring down the last term. Okay, now we have x and we want to make 10x. What would you multiply x by to get 10x? You'd multiply by 10. So we'll write that up on top. And the last step, multiply 10 by x to give me 10x, and then 10 by 3 to give me plus 30. Two new numbers, draw a line underneath, change the sign. That is going to give me 0 at the bottom because 10x minus 10x will give me 0. 30 minus 30 will also give me 0. So that is our long division completed. Okay, now you may be wondering, why do we bother revising junior cert long division? It is because we need long division for the factor theorem. Okay, so what we've actually shown there, we have shown that x plus 3, so what is our conclusion? We can say x plus 3 is a factor of 2x cubed minus 3x squared minus 17x plus 30. Okay, a factor is a number that will divide into another number. So for example, 5 is a factor of 10, because if you divide 5 into 10, it'll go in evenly, there'll be no remainder. Okay, here when we divided x plus 3 into this big long 2x cubed minus 3x squared minus 17x plus 30, we got a remainder of 0. That remainder of 0 shows that x plus 3 is a factor. Okay, we're going to be using this a lot when we come to the exam questions. So just make sure you are quite confident with your long division. If you do a few practice of them, it's almost muscle memory after that. You're going to know what number to divide into what. It can seem a little bit daunting at first, but do a few of them. Watch this video back to make sure you fully understand this example, and then you should be okay with it, hopefully. Okay, now into the factor theorem. Okay, so now that we have a rough idea of what a factor is, what we need to be able to do is we need to be able to switch between factors and roots. Okay, now we're going to talk more about them in a while, but first we're just going to do an example of switching between them. So if I have a root, okay, we don't really know what a root is yet, we'll come to that, but just bear with me for a second. So if I have a root of x equal to 2, okay, I can change that to a factor of x minus 2. Okay, so I can go from a root to a factor. How did I get the minus 2? Basically just subtract 2 from both sides to get 0 at one side of the equal to sign. Okay, I'm going to do another example where I'm going to start with the factor. So I'm going to say that x plus 4 is a factor. How do I go back up to a root then? Okay, we really have x plus 4 is equal to 0. Subtract 4 from both sides. My root is x is equal to minus 4. Okay, so a root will always be x is equal to a number, and a factor then will be x plus or minus a number. Okay, now if you want to show that something is a factor, so my first question over here on the left hand side, show x minus 1 is a factor of, sorry, now there should be powers there, so I'm just going to write those in quickly. So that's cubed, squared, and then over here as well, cubed and squared. Okay, we want to show that x minus 1 is a factor of 5x cubed minus 14x squared plus 12x minus 3. If you want to show that 5 is a factor of 10, all you have to do is show that 5 divides into 10. Here we need to do the same thing. So we need to show that x minus 1 divides into 5x cubed minus 14x squared plus 12x minus 3 with no remainder. Okay, so we're going to do that. So we have 5x cubed, we'll write it out as our long division. Okay, and we're going to do our long division like we did in the previous part. Okay, so first step, what would you multiply x by to get 5x cubed? You'd multiply it by 5x squared. And we need our two numbers down here, which we will get from, multiplying 5x squared by x and then by minus 1. So that'll be 5x cubed underneath there and minus 5x squared. Two numbers, change the signs. This will change to a minus and this will change to a plus. 5x cubed minus 5x cubed will cancel out, and we've got minus 14x squared plus 5x squared. That's going to give me minus 9x squared, and bring down the next number. From here then we repeat. So how many times, or what would you need to multiply x by to get minus 9x squared? You'd multiply it by minus 9x. Okay, we then need to fill in our two numbers here. So minus 9x multiplied by x will give me minus 9x squared. And minus 9x multiplied by minus 1, that would be plus 9x. Okay, draw your line, change your sign. So we then get minus 9x squared plus 9x squared cancel out. 12x minus 9x, that'll give me 3x. And we'll bring down the last number. And then what would you multiply x by to get 3x? You multiply it by 3. And then 3 multiplied by x will give me 3x. 3 multiplied by minus 1 will give me minus 3. Draw your line, change your signs. We end up with 0 at the bottom because they'll cancel each other out. And that is it. So we have actually shown that x minus 1 is a factor. So if we just want to kind of explain why, as remainder is 0, x minus 1 is a factor. Okay, that is that shown. If you make that conclusion, our next line then, so therefore, we can actually change between a factor and a root. So if we can say that x minus 1 is a factor, we can then say that x is equal to 1 is a root of 5x cubed minus 14x squared plus 12x minus 3. Okay, if we've shown that something is a factor, we can then change that factor into a root using what we did up there at the top. Okay, if x minus 1 is a factor, that's x minus 1 is equal to 0 plus 1 plus 1. We get x is equal to 1. We can say that that is a root. We haven't really discussed roots too much. We're going to do that now on the other side. Okay, but if you show that something is a factor, you can then conclude that you can also find your root. Now, on the other side, we are asked to show that x equal to 1 is a root of 5x cubed minus 14x squared plus 12x minus 3. Okay, we've shown it at the left-hand side. We've shown that it's a factor, and then we conclude that it's a root. There's another way I can show that something is a root. So if I want to show that something is a root, okay, basically to show that something is a root, sub in x equal to 1, and if it equals 0, then it is a root. Okay, so we want to test if x equal to 1 is a root. Okay, so everywhere there's an x, we're going to sub in 1. Okay, I'm going to put all of that into my calculator. And I get out 0. Okay, so when we sub in 1, we get an answer of 0. Therefore, x equal to 1 is a root. From this then, we can conclude if x equal to 1 is a root, we can also say that x minus 1 is a factor. Okay, we are going to be switching between these quite a lot. Okay, we need to be able to switch between these methods. Sometimes one is easier than the other depending on how the question is phrased. So obviously here, if you want to show that something is a factor, immediately just go to long division. If you want to show that something is a root, it's actually a lot quicker just to sub in the value instead of going through all this to be able to make the same conclusion. Okay, so we're going to be switching between them depending on what the question asks. Sometimes we'll have to do one or the other. You need to be able to do both ways. Okay, so that is kind of a quick run through of what the factor theorem is. Okay, we're going to go into the exam questions now and just see how it comes up. We're going to be using that kind of principle for most of the questions. Some of the questions will link in with functions as well, but when we get to those, we will just, they're only slight links that you should know from junior cert if you haven't done functions yet in school for leaving cert. So we're going to start with the 2021 question. Okay, now this isn't necessarily what we've covered, but we should still be able to do it. So f of x is equal to 3x squared plus 8x minus 35. We want to find the two roots when f of x is equal to 0. Okay, now this is actually a very straightforward question. So when f of x is equal to 0, f of x, they told us up here, is the same thing as 3x squared plus 8x minus 35. So they tell us f of x is equal to 0, which means they want when 3x squared plus 8x minus 35 is equal to 0. Now, there'll be other Saturday sessions on this. That is a quadratic. Solve a quadratic. I'm going to go for the minus b formula. Okay, here we've got a is equal to 3, b is equal to 8, and c is equal to minus 35. Okay, when I'm doing this, I put it straight into my calculator in one go. First, I'll press the plus button in front of the square root, and then I'll go up and change that to a minus. So I'd really encourage everyone just to make sure you can put this into your calculator. It's good practice. The quicker you can do this, the more time you will save in an exam. Okay, I get out one answer of 7/3. And my other answer, when I change the plus in front of the square root to the minus, I get minus 5. Okay, now they are two roots. The question doesn't ask us to go any further. There was a part 2, but not really linked to the factor theorem, so we'll just leave that question there. I just put it in, it shows roots, just it mentions the word root, and we should all be well able to do that, just applying the minus b formula there. Okay, moving on then, another question from 2021, which says x plus 4 is a factor of x cubed plus qx squared minus 22x plus 56. Okay, I'm going to pause there for a second and think, what does that sentence tell me? So that sentence tells me that x plus 4 will divide in with no remainder into that big long cubic equation. Show that q is equal to minus 5 and find 3 roots of f of x. Okay, so what we're going to do first, it says show that q is equal to minus 5. I'm going to look at what information they've given me. So first they've told me that x plus 4 is a factor. It's my factor. From that I can make a conclusion that x is equal to minus 4 is a root. Okay, what do I know about roots? I know that if I sub that root in, everywhere there's an x, if I put minus 4, that whole equation, so the x cubed plus qx squared minus 22x plus 56 should equal 0. So everywhere that there's an x, I'm going to put in the minus 4. I have the minus 4 everywhere there's an x. If it's a root, which we're told it is, or we're told that x plus 4 is a factor, so x equal to minus 4 is a root, that should all equal to 0. So I'm going to put in the individual parts into my calculator. So this is minus 64 plus minus 4 to be squared is plus 16. Q minus 22 by minus 4 is plus 88. Plus 56 is equal to 0. Tidy that up, so that will give us 16q. When you add those up, that'll give you plus 80 is equal to 0. Now just solve for q, so 16q is equal to minus 80. Divide both sides by 16. So negative 80 divided by 16, we're going to give me q is equal to 5, which is what I was looking for. Sorry, q is equal to minus 5 even. Minus 80 divided by 16 gives you minus 5. Okay, they told us what the answer should be. They told us that q is equal to minus 5. We got out minus 5. Okay, just very important there. That's our first switch between working with factors and with roots. Okay, if q is equal to minus 5, now I can rewrite my f of x as x cubed minus 5x squared minus 22x plus 56. Okay, just so we're not missing two unknowns. So that is our new cubic equation. Now, it wants us to find the 3 roots of f of x. So this is a new section that's going to come up quite a bit in the questions. So we know that x plus 4 is a factor. Okay, what I can do is I can divide x plus 4 into that big cubic. The answer we get then, we'll be able to get the other roots from that. Okay, I already know one of my other roots, I can actually write down here, is minus 4. Okay, it says to find the 3 roots, we'd found one root up here. Okay, so that's one root. I now need to find the others. So what I'm going to do first, I'm going to do long division to show because we know x plus 4 is a factor. Okay, so we have x plus 4 added into x cubed minus 5x squared minus 22x plus 56. Now, I'm going to get a bit quicker with my long division here. Just because we've done a few examples now, we should be a bit fairly confident with it. So what would I multiply x by to get x cubed? You'd multiply it by x squared. Okay, then multiply x squared by x to get x cubed. Multiply x squared by 4 will give me plus 4x squared. Change the signs. Give me minus 9x squared and bring down minus 22x. X to get minus 9x squared, you multiply by minus 9. X. Minus 9x by x, give me minus 9x squared. Minus 9x by 4, give me minus 36x. Change the signs. Minus 22x plus 36x will give me 14x plus 56. That'll give me plus 14 on top when I think what will I multiply x by to get 14x. So 14 multiplied by x will give me 14x. 14 multiplied by 4 will give me plus 56. Change the signs. We get 0 at the bottom. Now, that hasn't actually shown me anything new. Okay, they told us in the question that x plus 4 is a factor, which means it should divide in evenly. It has. Now, we need to find the other roots. Okay, what we can actually do, using this answer up here, okay, if I solve this or if I factorize this, it is going to give me the other factors and the other roots. Okay, so what I'm going to do, I'm going to take this, and you have a choice here. You can either factorize it or you can use the minus b formula. I'm going to factorize it. Okay, so number 14 here, what can I multiply to give me 14? I could multiply 14 by 1 or 7 by 2. Okay, I could also multiply minus 14 by minus 1 or minus 7 by minus 2. Okay, because we're looking for positive 14. What can I'm looking for the combination that will add to give me minus 9x. So that will be minus 7 and minus 2. Okay, so we have x minus 7 and x minus 2 is equal to 0. This line here, so these are my new factors. Okay, so it told us in the question that x plus 4 was a factor. Okay, because this is a cubic, it will have 3 factors. Okay, our factors now are x plus 4, we have x minus 7 and x minus 2. We can now make this into roots, so we have our factors. We can change those into roots. So we now have all our roots. So we had our root that we've had from the question when they told us that x plus 4 is a factor. So one of our roots is minus 4. The other 2 roots then are going to be 7 and 2. Okay, quite a lot of work in that question. Kind of a deceptively long question, but very doable if you can move between the roots and the factors. Okay, this concept here where you factorize your answer from your long division, we're going to see that again in exam questions. So when you factorize that, you can then find more roots or more factors. Because that was an x cubed there was going to be 3 factors, 3 roots. They may be repeated. Okay, so we'll see questions like that where you'll get the same answer out. but that is fine. There'll be 3 if it's a cubic and 2 if it's quadratic, but sometimes you may end up with the same numbers more than once. Okay, so we're going to move on now to the 2018 question. We're going to see a lot of that idea there. We're switching and we're doing our long division again. Okay, so this 2018 question. So they tell us that f of x is x cubed minus 17x squared plus 80x minus 64. Now, there's a bit of function notation here. If you haven't done a huge amount of work on functions yet, don't worry about it. I'm going to kind of translate it into language without the functions. But from junior cert, I think you should be able to get the grasp of this. So we want to show that f of 1 is equal to 0. Now, we're used to knowing f of x is equal to whatever. Okay, that then tells me that x is equal to 1. Okay, x is what's inside in the bracket. Okay, when something is equal to 0, we know things are equal to 0 when it's a root. Okay, so how I'd read that there, what's in the bracket is the x. I want it equal to 0. So basically what that's saying is show that x equal to 1 is a root. Okay, and then find another value of x for which f of x equal to 0. That's the second part. We will come to that. So showing f of 1 is equal to 0 is a fancy way of saying that show x equal to 1 is a root. If we want to show something as a root, we sub in 1 and the whole thing should equal to 0. Okay, put all of that into my calculator. And I hopefully get out. So I get out 0. Okay, so then just put a bit of a conclusion, show you that part done. We can say that f of 1 is equal to 0, or you can also just write x equal to 1 is a root. Okay, after that then it says find another value of x for which f of x is equal to 0. What is that really saying? Second part then is find another root. Okay, so we're looking for another x equal to whatever that you can sub in, that will give us out 0. Okay, now from what we've been given, we've shown that x equal to 1 is a root. Okay, we've shown it's a root. There's nothing more we can do with that, but we know we can go from a root to a factor. So we can say that x minus 1 is a factor. What can we do when we have a factor? We can do our long division. So we're going to long divide. We're going to divide x minus 1 into our cubic. Okay, now again, we'll go nice and quickly through our long division. So x into x cubed will go x squared. X squared multiplied by x will give me x cubed. X squared multiplied by minus 1 will give me minus x squared. Draw a line, change your signs. Minus 17x squared plus x squared will give me minus 16x squared. Bring down the plus 80x. X into minus 16x squared will go minus 16x times. Minus 16x multiplied by x will give me minus 16x squared. Minus 16x multiplied by minus 1 will give me plus 16x. Change our signs. Then we have 80 minus 16x, which will give me 64x. And then this will be minus 64. Then what would you multiply x by to get 64x? You would multiply by 64. And then 64 multiplied by x, 64x. 64 multiplied by minus 1, minus 64. Change your signs. You'll end up with 0. Now, all that long division, really all that is said is that x minus 1 is a factor because I got my remainder 0. But the real important bit is I've gotten this quadratic out of it. Okay, from that quadratic then I can find my other factors and then my other root. Okay, so we have our x squared minus 16x plus 64. Okay, what we're going to do is we're going to solve that. To solve it, I'm going to factorize. You can use your minus b formula if you prefer, but this is fairly straightforward to factorize. So to get 64, okay, you could multiply 64 by 1, 2 by 32. I want them to add to give minus 16x. So to get 64, you could multiply minus 8 by minus 8, and they'll add to give me minus 16x. So it's going to be x minus 8 by x minus 8 is equal to 0. Now that line there gives me my factors. Okay, now there are repeated factors, but we were only looking for another value. So one other value. To go from factors, so I can go to my roots. So I'm going to get x is equal to 8 for both of them. So that's what we call a repeated root. Kind of a separate topic. We will be coming to that in the discriminant section of this video. But my other root then is 8. Okay, so we wanted another x value up here. Their other value, when we sub in 8, we should get out 0. Okay, you can check that if you want. If you sub in 8 everywhere here, you should get out 0. Okay, as your answer. Okay, again, very similar to actually the last question we did, and this next question again is also going to show some similarities. So the function f of x such that f of x is equal to 2x cubed plus 5x squared minus 4x minus 3. Show that x equal to minus 3 is a root and find the other two roots. Okay, so be great. I think at this stage you should be able to pause this video and give it a go and then check back in with the video. I'm going to start it now and see how you get on. So first, to show that something is a root, sub it in. Okay, fire that into your calculator. We get out 0. Therefore, x equal to minus 3 is a root. Okay, now then it says find the other two roots. I've used the fact that x equal to minus 3 is a root. It's a root. Can't do any more with that, but I can move to factors. So if x equal to minus 3 is a root, then x plus 3 is our factor. If we know our factor, we can do our long division again. Okay, and we're going to do our long division nice and quickly here. So it could be 2x squared. Change signs. Okay, now I did my long division there and I got out 0 as a remainder. We've shown that x plus 3 is a factor. We already knew that because x minus 3 is a root. But we have gotten out our important quadratic up here, that if we factorize this, we can get our two other factors and then our two other roots. Okay, now this one here is a little bit more tricky to factorize. You can use the minus b formula here. We're looking for our roots, so I'm actually going to use the minus b formula just to show you can do this to get your roots, and then you have to work back up to your factors. Okay, so my minus b formula is my a, my b, and my c. So our minus b formula okay, on the front cover of your formula book. Okay, and put that into your calculator. So I get one answer of x equal to 1, and my other answer then, x is equal to minus a half. Okay, are my two other roots. Okay, you'll notice if you do your factorizing method, you get your factors first and then we can find our roots. If you do the minus b formula, you end up with your roots and then you'd have to work backwards to get your factors. Okay, but here we asked for our roots, so they are our other two answers. Okay, so the last question we're going to do for the factor theorem is the 2015 question. So it starts with solve the equation x cubed minus 3x squared minus 9x plus 11 is equal to 0. And then it says write any irrational solution in the form a plus b root c. Okay, so that's kind of hinting we're going to have some answers that maybe don't look as nice. So I'm expecting an answer that has a square root involved in it. Now, because this is a cubic, okay, there's an x cubed, we're going to have three solutions. Okay, now they don't tell us any of them, okay? So if I was to do this question, I'm expecting to maybe have a factor, do my long division, and then factorize the answer we get out from our long division to get our factors, and then our other solutions are our other roots. This isn't the case here. When this kind of a question comes up, they give you no hint to start. They give you no kind of first number that you know is a solution, okay, that will sub in and be correct. So what we're going to have to do, we're going to have to figure one out ourselves, okay? So we need to guess. Not maybe guess is the wrong word. Need to find one solution first. Now, when they don't tell you any, so we're going to try, let's try x equal to 0, x equal to 1. You could try x equal to minus 1. So their first solution, if they don't give you any, is going to be a nice number. Okay, so I'm going to try 0 everywhere. Okay, that gives me 11 equal to 0, which is not true. So x equal to 0 is not one of our solutions or one of our roots. Next, we'll try 1. So it'll be 1 cubed minus 3 by 1 squared minus 9 by 1 plus 11 is equal to 0. Put that into your calculator. You will get out 0 is equal to 0, which is correct. So x equal to 1, we don't need to try minus 1 then. X equal to 1 is a solution. Okay, now really a solution is another word for a root. Okay, so if we know x equal to 1 is a root, we're then going back to our factor theorem question. So x minus 1 is a factor. Okay, so we use trial and error to find our first solution. Okay, if I was to do this, I do it quite systematically just so I know I'm not missing any numbers. So I go 0, 1, 2, 3, 4, 5 maybe, and then go back minus 1, minus 2, minus 3. It's going to be a nice number for your first solution if they don't give you any to start with. Now that we know that x minus 1 is a factor, we can then do our long division. I'm going to divide that by x minus 1. Okay, now I actually have this long division done out, just we've done quite a few examples. Here's the solution to the long division. Just make sure you're able to get that answer and just do a bit of practice at it if you're stuck. But I do my long division, I get out 0 as a remainder. That is not a surprise because we know x minus 1 is a factor because x equal to 1 is a root. Now, why did I have to do that long division? I did that long division to get out this quadratic at the top. Okay, so x squared minus 2x minus 11 is equal to 0. Now, to find the other solutions or the other roots, we are going to solve that. There's two things. So first, I look at that. There's no obvious way to factorize that, so that won't factorize. Also, we know some of our answers are going to come out looking like this, which suggests that we're going to have to use the minus b formula. Okay, so our minus b formula, my a is going to be 1, b is going to be minus 2, and c is going to be minus 11. So we get x is equal to minus 2 plus minus square root of minus 2 squared minus 4 by 1 by minus 11 divided by 2 by 1. So when I put the plus in front of the square root first, okay, so just make sure you're practicing putting these into your calculator. It gives me out 1 plus 2 root 3. When I put the minus then, it gives me out 1 minus 2 root 3. Now, just going back up to the question, this here looked quite intimidating. So the way they wanted our answer at the start, a plus b root c, the calculator actually gives it out to us in that perfect form. So something plus something square root and something minus something square root. Okay, so they are my irrational solutions, and my rational solution then is x equal to 1. Okay, so if they don't give you any, trial and error to find the first one, and then you're back to your normal factor theorem style question. Okay, that is the end of what we're going to do with the factor theorem. We're now going to move on for the second half of the video. And so moving on to the discriminant. So the discriminant then, okay, so the formula for our discriminant is in the pink bubble there, so it's b squared minus 4ac. Now, you do need to know that, and they won't necessarily tell you to use the discriminant formula in the questions. When we get to the exam questions, you will see, but you should recognise that's just a bit from the square root, or from underneath the square root in the minus b formula. So b squared minus 4ac. There is quite a bit of learning, so basically everything on this page needs to be learnt, but we'll go through it step by step and try to understand it as well. So first, what is the discriminant used for? So this discriminant is used to check what kind of roots or what kind of solutions a quadratic has. Okay, so we're going to be using similar kind of terminology to the factor theorem. That's why I put them both in the same video. But we're going to deal with them kind of as separate concepts. So used to check what kind of roots or solutions a quadratic has. So this means if a quadratic curve intersects, touches, or does not intersect the x-axis. Okay, so we'll look at them separately first. So if b squared minus 4ac, so if you have your quadratics, you're going to be given a quadratic, you're going to know what a, b, and c are. Okay, if that is greater than 0, okay, this is what your, so if you find your discriminant and you find that it's greater than 0, this is what your curve will look like. Okay, if you wanted to find those 2 points where it crosses the x-axis, solve it using the minus b formula. You will get this point, x equal to this, and x equal to this. So here you have 2 real and distinct roots. So your quadratic will have 2 solutions. When you put it into the minus b formula, you'll get out your 2 answers. It cuts the x-axis at 2 different points. Okay, so that's if it's greater than 0, that is what your graph looks like, and that's what's going on. So you have 2 real and distinct roots. Distinct just means different. Okay, if you find b squared minus 4ac and it's equal to 0, you have 1 repeated root. Okay, your quadratic will have 1 solution. If you put it into the minus b formula, you'll get out 2 answers, but they'll both be the same. So you might get out x equal to 1 and x equal to 1. This means that the curve touches the x-axis, so it comes down and then it goes back up, but it just tips off the x-axis. So that's if your discriminant is equal to 0. And then if your discriminant is smaller than 0, there's no real roots, curve does not intersect the x-axis. Okay, so it doesn't cross the x-axis at all. That is if it's smaller than 0. Okay, we are then into complex roots for that. But all we need to know there are no real roots. Okay, so greater than 0, 2 real and distinct roots. We'll cut the x-axis twice. If you want to find those points, use the minus b formula. If it's equal to 0, it'll touch the x-axis, 1 repeated root. If you put it into the minus b formula, you'll get out the same answer twice. And if it is smaller than 0, your curve won't cross the x-axis at all, and you've no real roots. Okay, just down there is to remind what a, b, and c are. Same as if you're using the normal minus b formula. A is the number in front of the x squared, b is the number on its front of the x, and c is the number on its own. Okay, so we're going to get straight into the exam questions that come up in that, just because we are putting a focus on exam questions in these videos. Okay, so we're going to start with the 2022 question even. Okay, now this wasn't worth 30 marks. There is more underneath this, but it wasn't linked to the discriminant. Okay, now, anytime we see the word roots, solutions, we're thinking, okay, factor theorem or discriminants. Okay, here we want to know where it is exactly 1 solution. Okay, 1 solution, that points us towards the discriminant. Okay, so b squared minus 4ac. And when it has one solution, we know that's equal to 0. Okay, so it tells us one solution. That's b squared minus 4ac equal to 0. Okay, I haven't really read the question yet, but when I see exactly one solution, that's the first thing that pops to mind. Okay, so we're looking for the values of m. Okay, one solution, we have b squared minus 4ac is equal to 0. What can I fill into that? So I know a is equal to 3, number in front of the x squared. B is equal to minus m, the number in front of the x. And c is equal to 3. Now I'm actually looking to find the value of m. Okay, or the two values of m. So we're going to fill in what we know. So we've got b squared, so minus m to b squared, minus 4 by a by c. And that must equal to 0 because it has one solution. Minus m to b squared is just m squared, minus 4 by 3 by 3, that's minus 36, is equal to 0. Now, keep in mind, what are we looking for? We're looking for the values of m. So here I'm just going to solve for m. Okay, so m squared is equal to 36. Okay, so m is equal to plus or minus the square root of 36. So m is equal to plus 6. Or m is equal to minus 6. Okay, a lot of people, when they get to here, they forget that there's positive and negative answers. A lot of people might say m squared is equal to 36. So m is equal to 6, square root of 36. Then you go back up and you're like, two possible values of m. Okay, so then just pop your plus or minus in front. Okay, so m is equal to positive 6 or m is equal to minus 6. Why you get your two answers. So if m is equal to 6, m squared then will equal to 36. Or if m is equal to minus 6 to be squared is also equal to 36. Okay, so that's where you get your two possible answers. If you square 6, you'll get your 36. If you square negative 6, you'll also get your 36. Okay, because the minus number to be squared is positive. Okay, so your first question there, really a lot of it goes back to the learning of that note sheet that I had. Really everything on that needs to be learnt. Okay, part B then, explain why the following equation in x has no real solutions. So no real solutions, that is our discriminant, that's our hint to write down our discriminant b squared minus 4ac. If it has no real solutions, okay, what do we know when it has no real solutions? B squared minus 4ac is smaller than 0. Okay, that is what I got from this part of the question. Now, this looks weird. Okay, we haven't seen anything like that before. So what I'm actually going to do is I'm going to square that out. I'm going to multiply it out and get out my normal looking quadratic so I can find my a, b and c. Okay, so it's 2x plus 3 to be squared plus 7 is equal to 0. Okay, so we'll square out this. So that'll be 4x squared plus 6x plus 9. Tie that up, so 4x squared plus 12x plus 16 is equal to 0. Now, how did I know to do that? I know when I'm dealing with my discriminant, I like having a normal looking quadratic. This wasn't in that form, so I just changed it into that form, which is very handy because now I can write down that a is 4, b is 12, and c is 16. And now I can fill those into my knowledge from my discriminant. Okay, so we will have 12 squared minus 4 by a, which is 4 by c, which is 16. And that should equal something that is less than 0. Okay, so I'm going to pop that in. So 12 squared minus 4 by 16. That gives me out minus 112, which is less than 0. Okay, so the discriminant is less than 0, therefore no real solutions. Okay, so that was the 2022 part about the discriminant. Quite a nice question, I would say, if you know your knowledge from that note sheet that I had on the screen. If you want to go back and screenshot that, really everything on that needs to be learned for these questions. We're going to be using it a lot. Okay, so that's the 2022 question. We're going to go on now and look at the 2020 question. Okay, again, these are all very similar. So here they tell us that f of x is equal to x squared plus 5x plus p, and p is some integer, so it's a whole number, between -3 and 8. So find the two values for p. So I'm looking for two answers for which the graph f of x will not cross the x-axis. Okay, so it's going to look like quadratic that looks like that. Okay, doesn't cross the x-axis. That tells us that b squared minus 4ac is less than 0. Okay, does not cross the x-axis, same thing as saying has no real roots. So that's what our discriminant should look like. Now we need to write down a is equal to the number in front of the x squared, which is 1. B is the number in front of the x, which is 5. And c is the term without the x, so p. I'm going to fill in what I know. So it'll be 5 squared minus 4 by 1 by p. Okay, do what I can with this. So we get out that 25 minus 4p is less than 0. Here I'm looking for values for p, so I'm going to get p on its own. I'm going to solve for p. So we get, I'm going to say that 25, and then divide both sides by 4. So that is 25 divided by 4 is 6.25. Okay, so p is greater than 6.25 is what that says. Now, they asked us in the question for two values for p. So p is bigger than 6.25, okay? But up here, they told us that p has to be between -3 and 8, okay? It also has to be a whole number, okay? So a whole number that's bigger than 6.25, you could have p is equal to 7, and you can have p is equal to 8. Okay, they're both true for this because p has to be bigger than 6.25, and they work for up here, so p has to be between -3 and 8. Okay, a lot of times people tend not to read this kind of technical part of the question. Sometimes, all right, you can kind of scan over it and it may not really affect your answers. Here it was, okay, so if you get out here your inequality and you're like, they wanted two specific values and I've given them a range or an inequality, go back up, read it, figure out what your possible answers could be. Okay, so that was the 2020 question. We'll move on now to the 2017 question. Okay, now again, this was part of a longer question. I just took out the bit that was relevant to the discriminant. So, f of x is 2x squared minus 7x minus 10. Explain why f must have two real roots. Okay, two real roots. What do we know about two real roots? We know that b squared minus 4ac is bigger than 0. Okay, when something has two real roots. Okay, we know from our quadratic up here that a is equal to 2, b is equal to -7, and c is equal to -10. Okay, we're going to fill that into our discriminant formula. So it's going to be -7 squared minus 4 by 2 by -10. Okay, is this true? When I pop that into my calculator, I get out 129. Okay, 129 is greater than 0, so true. Therefore has two real roots. Okay, the discriminant formula I know for two real roots works out, so then it has to be true. Okay, and then part 2 then, not really the discriminant, but no harm, we'll just do it quickly. Write the roots of f of x equal to 0 in the form p plus or minus root q. Okay, so they have f of x equal to 0. We know from the question that f of x is 2x squared minus 7x minus 10 equal to 0. How do you solve that? You're going to go straight into your minus b formula. I'm going to leave that for you to do, but we should know, we should be fairly confident with that. That is just your minus b formula from there. Okay, so that is our discriminant. Okay, I'm just going to flick back quickly. This is the key page. So everything I did there comes from that page. You really need to know every detail that is on that page. Okay, what the graph looks like, the terms no real roots, a repeated real root, a real and distinct root. Okay, anything on that page there is your key information. Okay. So that is the Saturday session for today. So we looked at the factor theorem to find roots, factors, and we then looked at the discriminant to determine the number of roots of a quadratic, how the graph would look, finding values. So there's quite a lot in that. The question can vary, but it is all going back to b squared minus 4ac, whether it's greater than 0, equal to 0, or less than 0. Okay, so we focused a lot on exam questions today. That is kind of, they are the trends that tend to come up and the way the type of question needs to be asked. There are a few other kind of questions that can come up on these, but we just focused on our exam questions. Okay, so I hope you found this video helpful, and